Welcome to my lesson 3 of approximation, which is the 11th topic. So today our main concentration will be percentage error and approximation, percentage error. So we have two videos explaining what approximation is. So if you haven't followed the videos, please, I would advise you, before you watch this video, go back and watch lesson 1, lesson 2, then lesson 3 will be easy for you. Okay, let's begin. Percentage error. Now, percentage error, it is one way of trying to find the error that is bound to occur in percentages. That is what percentage error is about. So in order for you to find that error in percentage, the formula that you need to use is relative error times 100%. Relative error, remember, on lesson 2, we looked at what relative error is, on how to find the relative error. So the only thing you need to do for percentage error is to multiply relative error times 100%. Or alternatively, you can use another formula saying recorded value minus true value divided by true value times 100%. So you can use either formulas, you get your correct answer. Now, the first formula, it is very much applicable if only you have been given one dimension, meaning one true value. But if you have been given true value and also a recorded value, then this formula, the second formula, becomes also effective. So use these two formulas in different kind of questioning techniques. Okay, now let us look at the examples. Let us look at the examples. Okay. Oh, before I forget, on lesson 2, I left an example. I said you should finish this work. Let's say it was 5 over 5 divided by 5 divided by 100 and what is it? 500 and something. Okay, and remember the answer when we are trying to find the relative error. And we came to write our answer to be 5 over 650. So I said simplify this to get your final answer. I left a question mark. I believe some of you managed to answer it, but if you didn't answer it, the final answer for this one, relative error, it will be 1 over 130 as your final answer. Remember, these are paper 1 questions, so there is no need of writing my decimals. If you start writing decimals, you make life difficult for yourself. So just leave it in the simplest, lowest fraction form, and that will be your final answer. Okay, I fulfilled my promise. Now let's continue for today. So, now that we know what kind of formulas to use in percentage error, when we come to the example now, look at the first example. Find the percentage error of the diameter of bottle whose measure is taken to be 15. So remember, measure is taken to be 15.2 when its true diameter is 15 centimeter. Remember, they even said true diameter. So in this question, we already know that this is 15.2 is my recorded value, and the true value, it is 15 centimeter. Hence, they're asking us to find the diameter, to find the percentage error. So what are we going to do? Let us do the solutions here. So solutions, we write there. Solutions for question number 1. Question number 1, they are simply asking, so we need to identify. So percentage error, that is what we are looking at. Percentage error, what is the formula? Is equal to relative error, okay, times 100%. Or we can use alternatively, percentage error is simply going to be recorded value minus true value divided by true value times 100%. So we choose which formula to use from there. Okay, so this one I've just abbreviated it. We can use it like that if you memorize it and know it. Okay, so what is my recorded value? So the recorded value in this scenario, it is 15.2 centimeter. When its true value, it is 15. Okay, so let us use this formula. So we are simply going to say what is my recorded value? Recorded value, of course, it is 15.2 centimeter minus true value, which is 15 centimeter, divide by 15 centimeter, which is the true value, times 100%. Okay, so now what we need to do here, it is simply to simplify this. What are we going to do? 15.2, remember this is paper 1 questions. So in paper 1 question, examination questions. So what you do, you don't use a calculator here. So we are going to say 15.2 minus 15.0. So the 0 we just include it because this is just a whole number. So we have 0.2. 0.2 is my answer when I subtract this. So I have 0.2 centimeter divided by 15 times 100%. Okay, this is 15 centimeters. Okay, so now the centimeters will divide on each other. We cancel the centimeters. Then we have 0.2 divided by 15 times 100. Now remember, 0.2, it will be a complicated thing for us to multiply and divide with a decimal. So we need to know how to get rid of a decimal place or a decimal point. So how do we do it? We are going to say it is just equal to 1 decimal place. So we are going to multiply by 10. So it will be 0.2 times 10. 0.2 times 10 on both sides. The numerator and the denominator will multiply by 10. But we maintain the 100% there. So now we have 0.2 here. The only thing we do is to move the decimal place there, and then we have 2. Okay, 15 times 10, we have 150 times 100%. Okay, so now here what we need to do is to divide 2 into 15 into 150 and see how many times it can go. Then we have our we multiply with 100. And that will be our final answer. So let's try and say 2 there, it is 1. 2 into 15, how many times can 2 go into 15? So 2 into 14 goes how many times? 7 times. Remember what? 1. 2 into 10 goes how many times? 5. So 2 into 150 goes 75 times. Okay, it goes 75 times. So we have 1 over 75 times 100%. So in this scenario now, what do? We are simply going to say 100 times that, we have 100, okay, divide by 75, okay, percent. So here, this is not our final answer, okay, this is not our final answer. Our final answer will be, of course, when we simplify this in this simplest form. What will be our final answer? Our final answer will be, one number can go into 175 without leaving a remainder. Let's say 25. Okay, 25 into 100 goes how many times? 4 times. 25 into this goes how many times? 3 times. So the final answer now, percentage error. Okay, the percentage error that will occur in this, it is 4/3%. That will be the percentage error. 4/3%. Okay, I believe I've made this clear. That is how you can find this question number 1. The percentage error, that is how you find it. Okay, now let us see how to answer question number 1. We have done. Now let us come to question number 2. Okay, I will erase this question. Let's hope we are not erasing from your brains as well. Okay, let's see how to answer question number 2. So the formulas now stand. The formulas is just stand because the question is saying find the percentage error of the mass of a bag of sugar that weighs 10.00 kg correct to 2 decimal places. So how do we answer this one? Which formula will outstand this one? Okay, now look at this one. We have not been given the recorded value, but we only have the true value, which is 10.002. So this formula cannot stand in this scenario. What will stand? It is this one. So now we are going to say percentage error, okay, is equal to relative error times 100%. Okay, so now do I know my relative error? How to find the relative error? Do I know? That we looked at it in lesson 2. Of course, this is lesson 3. Lesson 2, we looked at it. So how do I find my relative error? It is simple as doing like this. So let us find the relative error first. Relative error, it is simply, we are simply going to say recorded value minus true value divided by true value. But here we don't have any of those. So we are simply going to say it is absolute error divided by true value. Okay? Absolute error divided by true value. So in this scenario, we need to find our absolute error again. So how do I get to find the absolute error? So the absolute error, it is simply looking at the, it is simply lam divided by 2. Okay? So this is how we need to work it out. Divide by 2. So now what is my lam? Remember, lam is a short way of writing least unit of measurement divided by 2. So we need to find the least unit of measurement, and that is will be our, then we divide by the original true value. So what is my lam? We look at the value that they have given you. The true value, it is 10.00. Now 10.00 kg, how many decimal places, how many decimal number does it have? It has 2 decimal places. Okay, 2 decimal places. So my lam for this kind of a question, so lam for this one is going to be 0.01 because it has 2 decimal places. So since I found my lam there, all I need to do is to divide by 2. When I divide by 2, I would have found my absolute error, and I replace there, divide by true value, then I found my relative error, and I multiply by 100. So what do I do next here? I need to divide this by 2. So how do I divide this by 2? I'm just going to say multiply both sides by 100. So it will be 0.01 divided by 2, multiply by 100, even this I multiply by 100. So that I can get rid of the decimal place. So I have 1 over 200. 1 over 200. Okay, so 1 over 200 is what I have. Now this, it is the absolute error. That is the absolute error. Of course, you can leave it there or write it in decimal place. How can I write it in decimal place? Of course, you can 200 into this one, you are going to have your answer. Now, let me divide 200 into this one. We are going to say, what is 200 into this one? We have 0 point, we add the 0, 0, another 0, 100, 0. Then 200 into 1000, we just cancel this and this. 2 into 10, we have 5. So the absolute error, it is 0.005. So we replace now here, we have 0.005 divided by the true value, which is the 10.00. Okay, 10.00. So now what do we do next here? In order for me to divide this, I need to multiply with what? 1, 2, 3 with the 1000. So we are going to say, okay, 0.005 times 1000. Also we do the same here, 10.00 times 1000. Okay, what do we have? We move the decimal place. 1, 2, 3. So we have 5. Okay, divide 0, 0, 0, of course, but we just leave it like this. Then we have, again, we move this decimal place. 1, 2, 3. Okay, because there are 3 zeros. So it will be 10, 1, 2, 3. 10,000. Now we divide this into that. What do we get? Okay, what do we get when we divide this into that? We are going to have 10,000 into 5 into 5. Of course, it is 0. Okay, 0. Then we have point. We will put a 0 there, we put a point and we add a 0 there. 10 into this one, it can't. We add another 0 there. And then we put a 0 there. 10 into this one, it can't. So 10 into this one, it can't. We add a 0 there and another 0 there. Just like that. Then 10 now into this one, what do we have? Let us not use this method, but instead let us use this method. Okay. 5 into 5 is 1. 5 into 10 is 2. So I simply have 1 over 200. That is the easy way to do it. So now we have found what my relative error is. This is my relative error. I found my relative error. So now when you find your relative error, now just replace on the formula here. Okay, so we have 1 over 200 times 100. Then that will be your final answer. So now 1 over 200 times 100. Okay, 1 over 200 times 100. What do we have now? We are simply going to say 1 times 100, we have 100 divided by 200. So what do we have? Okay, no, not 200 by, this is suppose 1, 2, 3, by 2000, not 200, 2000. So what do we have next? We have to divide this into there, cancel this and this there, cancel that. Then we have, okay, then we have 1 over 20%. So this will be my final answer as my percentage error, which will be 1 over 20%. As you can see, this one, it is involving, it takes a lot of concept. If you missed one lesson video, then it means that you cannot be able to answer this kind of a question by watching this video alone. So you need to have this knowledge of how to find the absolute error, and you need to know how to find the relative error. Then you can be able to answer the percentage error. So it is each concept, it is pushing you to do something intense. As you can see, we have spent a lot of time just to find 1 over 20%, the error that can occur in what? 10.00 kg. In percentage, we have 1 over 20. You can write this in decimals if you want, but I would prefer you leaving it like that, as in percentages. Okay, good. So now that is how you answer that question. Now let us come to another question, question 3, of course. Now, question 3, it is a mixture now of whatever we have been doing there. Elena measured the length of a line to be 2.2 centimeter. If the actual length is 2 centimeter, find the A, absolute error, B, percentage error. So now here they are to see, let's see if you have understood all the lesson videos that we have made so far. Okay, can you answer absolute error? Yes. Can you answer percentage error according to the knowledge that we have already done here? Yes. Therefore, now this should be easy for you. All these are examination questions. ECZ examination questions. Of course, this is grade 12 examination question paper. Paper 1. That is where you find these questions. So we are answering some of the questions already. Okay, now let us answer question number 3. Okay, question number 3. Let us answer question number 3. Okay, so I'll erase this part. Hopefully I'm not erasing your brain, the knowledge that is already in your brain. Okay, let's see now. How can we answer this question? Elena measured the length of a line to be 2.2 centimeter. If the actual length is 2 centimeter, find the so question number 3A. So we are told to find the absolute value. So absolute value. That is, we are told to find, or you can have abbreviated absolute what? Absolute what? Not error, not value, but error. Oh, that is my mistake. Absolute error. You can abbreviate it as AE to represent absolute error. Now, you need to know the formula for finding the absolute error. So when you know the formula, then the rest becomes easy. So let us say absolute error, which is abbreviated as AE, it is equal to, what is the formula that is used to find the absolute error? Of course, I can use the, it can be, let's use the lamp divided by 2. Or alternatively, you can say absolute error is equal to recorded value minus true, okay, value. Alternatively, you can use these formulas. Okay, you choose which one is good for you. Remember, LAM simply stands for least unit of measurement divided by 2. That is what it stands for. So now, which formula will stand for this question now? So, absolute error, we have been taught that this Elena measured 2.2. So 2.2, this is what we call the recorded value. And then we are saying actual length is 2 centimeters. So how do I find this one? So I will use the first one, this one, the second formula. So this one is the one which will stick. So now, for me to find the absolute error now, absolute error, it's going to be, what is my recorded value? It is 2.2 centimeters minus, what is my true value? 2. Then what is my absolute error in this scenario? My absolute error, it is going to be 2 minus this one to be 0.2 centimeters. 0.2 centimeters. That is my absolute error in this scenario. Okay, that is my absolute error in this scenario. So once you have found your absolute error, therefore now you can come to answer the question, percentage error. How do I get to find the percentage error? Okay, the percentage error in this scenario, B. Okay, percentage error, I know the formula by now. Simply say percentage error, it is either I use the second formula, recorded value minus true value, divided by true value times 100, or I can use relative error. So the easiest way, it is simply, I already know the recorded value, so I just simply say what is recorded value minus true value over true value times 100%. So what is my recorded value? It is 2.2 centimeter minus, what is my true value? 2 centimeter divided by 2 times 100. Okay. Therefore now, what do I do next? I need to subtract these two. I have 0.2 divided by 2 times 100. How do I get rid of 0.2? By multiplying, of course. I need to multiply. Okay, so we are simply saying 0.2 times 10. Again, this one, 2 times 10. I will have 0.2, we have 2 divided by 20 times 100%. Okay, 100%. So what do I do here? I just have to multiply this times that, which will be 200, or this times this, divide this by that. We have 1 there, we have 1 there, we have 10. So 10 times 100%. So my final answer, therefore, it will be 1000%. Okay? No. Not 1000%, of course, it cannot be. It cannot make sense. So we have 1 over 10 times 1000, 100%. So we multiply this, we have 100% times, divide by 10, cancel this, so we have 10%. So 10% is our final answer for this one. So the percentage error, it is simply 10%. 10%, that's our percentage error. Hopefully this was helpful. The last piece of work, which is upper limit and lower limits and percentage error, I expect you to be able to answer this question without any problem. Remember, when you are given percentage error, we have been given what we call the true value and the recorded value. All you need to do is to simply apply it like this and find your final answer. So 2 into 20, it is 10, 2 into there, it is 1. So we are going to say 1 over 10 times 100. Okay? Then you multiply this and you find your final answer to be 10%. So the error that is bound to occur in the measurement in this length which the learner did, it is 10%. Okay, so please, if you have not subscribed yet in my YouTube channel, please do subscribe so that you can get the notification bell each and every time I post new videos, and you'll be able to follow at accurate times, and I don't want you to be behind. And pause the video, write the notes in your books so that you can easily use it as a reference just in case your battery goes off on your phone or your tablet or iPhone or anything that you are using electronically to watch this video. Otherwise, we'll end from here. Do finish this as your assignment. This will be your task. Do answer this as your task, and then we shall see the answers in the next video for this question, and that is how we shall end. As for now, enjoy your time and God bless. Bye bye for now.